Hi Year 12s. In this video I just wanted to quickly go over a little bit about working with sectors. I briefly mentioned a little bit about it. There were some questions in the booklet that you were given, and I have been asked by a couple of people about it, so just wanted to quickly do a video showing how to deal with sectors. And so basically a sector is a piece that's been cut out of a full circle. So here we've got a 120 degree sector. Now, for dealing with circles, we do have some rules that would help us deal with a circle. For instance, if we wanted the area of a circle, the rule we have, or the equation, is the area of a circle is pi r squared, where r is the radius, which is half the distance across a full circle. And so in this case, we would consider the 4.5 as the radius. If we imagined our circle going round, this line here is the radius. And as a matter of fact, this one here is also the same. So that would also be 4.5. So if we have a sector and we know one of the sides there, the other side is going to be the same. Now, in terms of finding the area for this, if we imagine that it was a full circle, the calculation that we'd be doing would be pi times 4.5 squared, and that would give us the area of the full circle. Now, since we don't have a full circle, we've got a chunk out of the circle. What we can do is we can times by the fraction of the circle that we have. And so we've got 120 degrees. Now, a full circle is 360 degrees. So essentially, we've got 120 out of 360. That's the fraction of the full circle that we have. And so if we calculated that, that would give us the area, which would be in centimetres squared. And so, yeah, you can calculate it that way. Now, aside from area, we might be interested to know that the distance along here, along this curved part, and we could do a similar thing. We have circumference of a circle. The formula or equation is 2 pi r. And so since we have we don't have a full circle, we've got 120 out of the 360 degrees of a full circle, that can times by 2 pi r, which is 4.5, and then we could do that calculation, and that would give us this curved distance. All right, so hopefully that makes sense in terms of dealing with sectors a little bit there. And if you deal with this stuff, often the questions and the way you'll have to apply it will be a bit more involved than just, say, finding the area. It may be that you're dealing with something where you've got a line across there. You might be needing to just find this part. You might be finding the area of that section and not the full sector. And so using a bit of kind of measurement kind of thinking and your understanding of area, you might also be able to calculate the area of this triangle. Your full sector area, take away the area of the triangle, would be a way to calculate that, for instance. But you just have to work flexibly depending on the situation and the question that you're dealing with.